Hello and welcome to week 16 or episode 16 of Quality Quant Questions. This week we take up questions from functions, standard questions from functions. First question, if f of x plus y is equal to fx into fy and f4 is equal to 4096, then find f10. This is fine. What we can do is we can break this down as f2 plus 2 is equal to f2 into f2. We know this is f4. This is equal to 4096, which tells us f2 whole square is equal to 64 square, or f2 is equal to 64. You can get to this. Now, moving on further, we have to find out f10. Now see, f10, I can write it as f8 plus 2, which will make it f8 into f2. This f8 can be written as f of 6 plus 2 multiplied by f2 on the outside. Now this 6 plus 2 can be broken down as f6, f2, f2. And hopefully you can see where this process is going. We're essentially going to break down 10 into 5 f2s, or f10 is equal to f2 raised to the power 5, which will be equal to 64 raised to the power 5. Now, though all the options are 2 raised to the power something, this would have to be 2 raised to the power 6 raised to the power 5, or 2 raised to the power 30, or option C is the right answer here. Okay, moving on. Here we have fxy is equal to fx plus fy for all positive values of x. f3 is equal to 1. Then something is given to us. The fun thing here is we don't really need this value at all. We don't really need this value at all. What we do, however, need is this expression. Look at this. f243. Can I write this as f of 3 into 81 and f243 is f of 3 into 81, which can be broken down as f of 3 plus f of 81, or and now f of 27 similarly can be written as f of 3 into 9, which will break it down as f of 3 plus f of 9. Now, if you replace them in the fraction here, we will have f3 plus f81 minus f81, and whole thing divided by f3 plus f9 minus f9. These two portions will cancel each other out. We've got something divided by something. Of course, the value of this fraction has to be equal to 1. Of course, the value of this fraction has to be equal to 1. This is one way of doing it. Another way of doing it is, see, this relation is only valid. This relation is only valid if f of x is equal to log x to the base a, some random base. fx is equal to log x. This is an indication of log x, log related or index related function. Why this is useful is, see, if fx is this, see what would happen on the right hand side. We would have log ax plus log ay. On the left hand side we get log a xy. Yes, this relation holds. Log a plus log b is equal to log ab. This relation holds. With this knowledge in mind, we can also go ahead and reconfigure these terms. We can also go ahead and reconfigure these terms, which would give us log a 243 minus log a 81 by log a 27 minus log a 9. Now all of these are powers of 3. So it will turn to 5 times of log 3 to the base a minus 4 times of log 3 to the base a divided by 3 times of log 3 to the base a minus 2 times of log 3 to the base a, which will then make it 1. Which will then make it 1. Another way you can break it down is, see, f of x square is going to be f of x square, x into x is going to be 2 times of fx, 2 times of fx, or f of x cube is going to be 3 times of fx, or f of f raised to the x raised to the power 4 is going to be 4 times of fx. Why this is wonderful is, again, these are all powers of 3. We can rewrite this as 3 raised to the power 5 minus f of 3 raised to the power 4 by f of 3 raised to the power 3 minus f of 3 raised to the power 2, which will then bring us to 5 times of f3 minus 4 times of f3 by 3 times of f3 minus 2 times of f3, which will again lead us to 1. So you could solve it in any way. This is process 1, this is process 2, this is process 3. Why I've mentioned all these different ways is, one, I wanted to get this idea across. If 2 terms multiplying on one side and 2 terms getting added on the other side, this only works when log-based function is involved. I wanted to get this idea across, and I wanted to show there are different ways of approaching the question. Regardless of what path you choose, you will get, as long as you are true to the principles of mathematics, you will get to the right answer. Moving on, next question now. This is also fun. 4 fx is equal to 4 raised to the power x, 4 raised to the power x plus 2. Then f1 by 1997 plus f2 by 1997, so on and so forth, up until f of 1996 by 1997. Now here, what you have to notice is, see, this term and this term add up to give us 1. 1 by 1997 and 1996 by 1997 add up to give us 1. So, if fx is this, next thing we should be checking for is f of 1 minus x. What does this give me? This will be equal to 4 raised to the power 1 minus x divided by 4 raised to the power 1 minus x plus 2, which will translate to 4 divided by 4 raised to the power x, whole thing divided by 4 divided by 4 raised to the power x plus 2, which will then translate to 4 by 4 plus 2 into 4 raised to the power x. I can get 2 cancelled out from every place. So write 2 by 2 plus 4 raised to the power x. So fx is this, f of 1 minus x is this. So fx plus f of 1 minus x will be equal to 4 raised to the power x plus 2, because the denominator is identical in both cases. 4 raised to the power x plus 2 divided by 4 raised to the power x plus 2, which is equal to 1. Which means every pairing, first term and the last term, second term and the second last term, third term and the third last term, or every pairing that I make, I will be getting 1 every time. And how many pairings can I make? There are 1996 terms. In every pair, there are 2 terms. So how many pairings can I make? It will be 1996 divided by 2, which is equal to 998 pairings. And every pairing returns 1. So the answer to this question will be option C. Okay. Next question now. Fx is equal to ax plus b, linear function, where a and b are constants. F of x is equal to 125x plus 217. Then find the value of 7a minus 5b. Okay. Let us try to open this. This is a function of a function. So f of x. If I try to open it, I'll have f of fx is already known to us as ax plus b. So if I open this up, I will get f of a times of ax plus b plus b. So let me open up the portion inside itself. I'll get f of a square x plus ab plus b, or this will be a times of a square x plus ab plus b plus b. So when I open this even further, I get a cube x plus a square b plus ab plus b. This is what we have. And now this has been told to us as equal to 125x plus 270. So this portion should be 270 because this is the constant portion. This a cube should be 125, which gives us a clear indication a has to be equal to 5. Once a is equal to 5, look at this part, second part. A square b is 25b, ab is 5b plus b. So 31b is equal to 217, or b is equal to 7. We have the value of a identified, we have the value of b identified. So we can get to 7 into 5 minus 5 into 7. The difference between them, of course, will be 0, or option A is the answer. Next, what is the maximum value of this min function? Now, see, you should be able to arrive at this answer graphically. Not every question requires you to create a graph, but for this particular question, you should be able to arrive at the answer of this question graphically. How that graph would be created is, look at the first expression, linear expression. The root is -2 and the slope is 1. The graph will go something like this. For the second expression, root will be equal to 3/4. The slope of the line is slope here is 1, slope here is 3. So it will go something like this. Something like this. Now, if we are looking for the min function, it is going to be this part. It is going to be this part of the min function. This part of the both the curves. The upper part is to be ignored. The bottom part is to be taken care of. Now, what is the maximum value? The maximum value is going to be attained here because on the left-hand side, under it, you are getting a minimum value. The right-hand side, under it, you're getting a minimum value. So where do you get the maximum value of this min function? It is going to be here. Now, this is the graphical understanding of it. For the purposes of solving, you don't need to draw this entire thing. All you need to do is, can you see this is simply the point where these two expressions are identical. So all you do is x plus 2 is equal to 4 minus 3x, or 4x is equal to 2 at x equal to half. At x equal to half is where you get your maximum value of this function. Remember, this gives you at x equal to half, this value would be obtained. Now at x equal to half, this term would be 2.5. And 4 minus 1.5, this term would also be 2.5. So maximum value of the function is 2.5. For what value of x is this attained? It is attained at x equal to 0.5. So in such questions, also one of the traps is sometimes they'll ask you the maximum value of the function. Sometimes they'll ask you the maximum value of the function is obtained at which value of x. So please read the question very carefully. Okay. Next, if gx is equal to 8x minus 9 and hx is equal to 9x plus 8 and 2 times of g of ha and h of ga, then a is equal. Okay. HOGA, hog A. What this means is H of G of A. And we know G of A. G of A is 8x minus 9. So this is as good as H of 8A minus 9. And we also know this means this is equivalent to 9 times of 8A minus 9. Or this is equivalent to 72A minus 81. H of G of A is 72A minus 81. Now let us do G of H of A. Hopefully this processing is understood. So I will directly jump to G of HA will be 8 times of 9x plus 8 minus 9. Directly we can jump here, which will get us to 72x plus 64 minus 9 plus 55. Now we are told 2 times of this is equal to 72 is equal to this. So 2 times of this is 144x plus 110 is equal to 72. Have I done a mistake here? It should also be plus 8. I forgotten the plus 8. So 81, so minus 73. 72a minus 73 has to be the expression here. 72a minus 73. This comes over to this side, this comes over to this side. We get 72a is equal to minus 183, or a is equal to minus 183 by 72, or option A is the right answer. Next, if h of x minus 2 is equal to 4 times of hx square minus 5, find h of x minus 4. Now see, for some series or for some function, the current term is 4 times 2 terms forward ka square, 4 times of 2 terms forward ka square minus 5. So if we are looking for h of x minus 4, the relationship between h of x minus 4 and h of x minus 2 is the same relationship that h of x minus 2 has the relationship with h of x. For ease of writing stuff down, I am calling hx as A, this is B, this is C. Can I say, if I call it ABC, what it would turn to is B is equal to 4a square minus 5. And we also know C is equal to 4b square minus 5. I can replace B from here, which will give us C is equal to 4 times of 4a square minus 5 whole square minus 5. This is the stuff we are going for. So you will have 4 times of 16a square plus 25 minus 40a square minus 5. I open it all up, I get not 16a square, this will be 16a raised to the power 4, 64a raised to the power 4 plus 100 minus 5, so plus 95 minus 160a square. Remember, a was hx. All the options are given in hx. Which of these has the same coefficients as the option? Clearly, that is true for option D. So that will be our answer. Next. This is another fun setup. 3fx plus 2 times of 1 minus x is equal to x square plus 4. Find f3. I'm looking for F3. First thing I do is I put down X equal to 3. So 3 times of F3 plus 2 times of F of minus 2 is equal to 9 plus 4 or 13. We are looking to find value of F3. But there is another unknown involved, F of minus 2. So this time put down F of minus 2. Put X equal to minus 2. So we'll get 3 times of F of minus 2 plus 2 times of F of, see this wonderful thing, 1 minus minus 2 is 3 only, F3, and this is equal to minus 2 whole square is, minus 2 whole square is 4, 4 plus 4, 8. Now, you can use simultaneous equation ideas, or what you can simply do is, you can solve it in whatever way you feel most comfortable. I am going to use this. See, sorry, this 5 times of F3 plus F of minus 2 is equal to 21, or F3 plus F of minus 2 is equal to 21 by 5. Now look at the first expression. It has 2 times of F3, 2 times of F of minus 2, and an additional F3. So can I say left hand side is F3 plus 2 times of 21 by 5 is equal to 13. This here, if I bring it over to the other side, I will get 65 minus 42 by 5. F3 here, this will be equal to 23 by 5. And our answer will get maintained. Our answer will be identified. If we want to solve it simultaneously, we can also do that. We multiply this by 3, we multiply this by 2. Okay, I also want to show you a thing about multiplication by 3 and multiplication by 2. This simultaneous solving, and it is not just for functions. Hopefully you can see here, people after the multiplication, they tend to write down the full expressions. You don't really need to write down the full expression. You know, we have taken numbers such that these F2 get cancelled. 3 into 3 F3 is 9 F3, 2 into 2 F3 is 4 F3. So the difference is going to be 5 F3. Additionally, 13 into 3 is 39, 8 into 2 is 16, 39 minus 16 is 23. So F3 is equal to 23 by 5. You don't need to write the full expressions. If they are simple numbers, if they are numbers that are manageable, that you can get them across in your head, then do it mentally. Don't write everything down. The more you write it down, the slower your solving will be, which is not an ideal state to be. Next, if fx is 3x plus 4 and gx is 4x minus 3, then f of gx and g of fx is equal to, okay, 3 times of 4x minus 3 plus 4 times of 3x plus 4. This is what has been asked of us to accomplish. But here we also have a plus 4, and here we also have a minus 3. Now you can choose to solve it in entirety. You can choose to solve it in entirety, or you can choose to focus only on the constant part. Here you have plus 12, here you have plus 8, here you have minus 8, and here you have minus 12. So I'm doing 3 into minus 3 is minus 9, and this is minus 3, minus 12. 4 into 4 is 16, plus 4 is 20. 20 minus 12, 8, plus 8 I'm getting. So this is my answer. This we can mark straight away. If we want to complete it in entirety, we will of course go ahead and write down 12x minus 9 plus 4 plus 12x plus 16 minus 3, which will then lead us to 12x plus 8. The working is not going to change drastically. The answer will of course remain the same. The fact that all the constant portions here were different, you could have only focused on the constant portion and arrived at your answer. Okay. This one now. 1 by x of fx minus 3 times of f of 1 by x is equal to 3 by 2 for all x not equal to 0. Then f3 is equal. Utilizing we learned earlier, something we learned earlier, let x be equal to 3. So we have 1 by 3 f of 3 minus 3 times of f of, sorry, 3 times of f of 1 by 3 is equal to 3 by 2. Now the challenge with this is we want to figure out the value of f3. We also have to figure out the value of f of 1 by 3. So in the next iteration, in the next writing, we will have f of x equal to 1 by 3. If x equal to 1 by 3, 1 by 1 by 3 is equal to 3. So we have 3 times of f of 1 by 3. This is in positive. Minus 3 times of f of 3. This is also equal to 3 by 2. So we simply add these two up. We simply add these two up. When we add these two up, here we get minus 8 by 3 f3 is equal to 3 by 2 and 3 by 2 is equal to 3, or f3 is equal to 9 by minus 8 or minus 9 by 8, which is what finally the question demanded of us. Answer to this question will be minus 9 by 8. Okay, moving on. If fx plus y is equal to fx into xy. Hopefully we remember this expression because this gets used very often. We remember this expression. For all xy belonging to real numbers and fa is equal to 3, find the value of f20a. This is as good as a plus a plus a plus a plus a. So this is as good as f a has to be log forget it, f20a, can I break it down as f of a plus a plus a plus summate times 20 times. So it is going to be fa raised to the power 20, which will be equal to 3 raised to the power 20, or option C will be the answer. Okay, let's go. Next one. If fx is equal to 8x raised to the power 4 and gx is equal to cube root of fx, find the value of log fog 64 to the base 2. Now see, don't try to solve everything in one go, small parts. First would be f of g64. First, let us find out g64. G64 will be how much? G64 will be equal to cube root of 8 times of 64 raised to the power 4, which is cube root of 2 cube into 2 raised to the power 6 into 4. So 2 raised to the power 24, or cube root of 2 raised to the power 27, which is equal to 2 raised to the power 9. Now fog 64, FOG 64 is going to be 8 times of 2 raised to the power 9 raised to the power 4, which is going to be 2 raised to the power 3 into 2 raised to the power 36, or 2 raised to the power 39. Our final expression that we're seeking is log to the base 2, 2 raised to the power 39. This 39 will come to the front, and log 2 to the base 2 is 1. So the final value of this expression will be option A, 39. Okay. Next question now. Let fx be a function satisfying fx into fy is equal to fxy for all real xy. If f2 is equal to 4, then what is the value of f half? Okay. First thing we should look at is, see, in such questions, when two multiplying terms and the individual variables are also multiplying as an fx here, you should ideally be looking to find f1. When it is summation, you should be looking for f0, because 0 is the identity number for addition, 1 is the identity number for multiplication. Is multiplication happening here? So let's go. f2 into 1 is going to be f2 into f1. f2 into 1 is f2 only, so this is 4. f2 is 4 into f1. So f1 will be equal to 1. We know this. If f1 is 1, can I say f of 2 into half, this is f1, will be equal to f2 into f of half. This we know to be 1. This we know to be 4. So figuring out f of half will not be a challenge. F of half will be equal to 1 by 4. This is done. Next, this is the first question that will sort of spin you. Let's see, if 3 times of f of x plus 2 plus 4 times of f of 1 by x plus 2 is equal to 4x, then f4 is equal to. Understand, if we are looking for f of 4, if we are looking for f of 4, then what sort of value do we need to assign to x? What sort of value do we need to assign to x? X has to be equal to 2. X has to be equal to 2. So we will have 3 times of f of 4 plus 4 times of f of 1 by 4 is going to be equal to 4 times of 2. This is going to be equal to 8. This is going to be equal to 8. Now the challenge becomes, we have a 1 by 4 involved. We have a 1 by 4 involved. So x plus 2 has to be equal to 1 by 4. X plus 2 has to be equal to 1 by 4. If x plus 2 is equal to 1 by 4, x is equal to minus 7 by 4. X has to be equal to minus 7 by 4. So we get 3 times of f of 1 by 4 plus 4 times of f of 4 is equal to minus 7. This is very important. This is why this 4x, the value of this 4x is determined by what value of x we end up taking. With this in mind, then we solve. Now see, again, because we have to solve it quadratically, I want to get rid of f1 by 4. So this will get multiplied by 3. This will get multiplied by 4. This will get multiplied by 3. This will get multiplied by 4. So I will have 1 by 4 get cancelled. 3 into 3, 4 into 4. So 16 minus 9 will give us 7. I will have 7 times of f4, and 28 minus 24 will give us minus 52, or f4 is going to be minus 52 by 7. Sadly, none of the options align. So the correct answer to this question has to be none of these. So you have to simply be careful. What the value of x gets us to what we want to solve. A more technical, bland way of solving this is, of course, let x plus 2 be equal to z. The bookish way will be x plus 2 is equal to z. So z is equal to, sorry, x is equal to z minus 2. Z and 2 are too similar, no? So let me use another variable. X plus 2 be equal to y. So x is equal to y minus 2. So this function will then change to 3 times of Fy plus 4 times of 1 by y is equal to 4y minus 2, or this will turn to 4y minus 8. Now you can go ahead and replace y is equal to 4. If y is equal to 4, then 3 times of f4 plus 4 times of 1 by 4 is equal to 4 into 4 minus 8 gives me 8. Now 1 by 4 is needed. So we'll take y equal to 1 by 4, which will give us 3 times of f of 1 by 4 plus 4 times of f of 4 is equal to 1 minus 8, so minus 7. Hopefully you see the equations that we are arriving at here and the equations that we are arriving at here, they are identical. It is just that this is the more technical bookish way of resolving the conundrum, and this is more observational. If I want f4, I want the portion that is coming within the brackets after the f part as 4. So x equal to 2 would serve the purpose, or x equal to minus 7 by 4 would serve the purpose. In either case, you can solve. Whichever one gets you to the answer will be the right one. The right answer here, of course, is option D, none of these. Sorry. Next question. Here we have f1 is equal to 1, f2 is equal to 1, and f3 is equal to minus 1. And fn is equal to f of n minus 1 into f of n minus 3 for n greater than 3. Then the value of f of 694 plus 694. Now, the idea here is, of course, they do not expect you, they cannot possibly expect you to calculate all the way up until f694, which means after some iterations, there is going to be some sort of repetition happening. So let's see what is the repetition work that is happening. f1 is equal to 1, f2 is equal to 1, f3 is equal to minus 1. Now f4, it has been defined as minus 1 into 1. The minus 1 into this, so it will get me minus 1. f5 will be equal to minus 1 into 1, will get me minus 1. f6 will be equal to minus 1 into minus 1, or 1. f7 will be equal to 1 into minus 1, so minus 1. f8 will be minus 1 into minus 1, so again 1. f9 will be 1 into 1, so 1 again. f10 will be, see, when you're trying to identify a sequence like this, don't try to force it. No, after these many terms, after that, those many terms. Don't try to force it. Naturally, wherever we get it, that is where we go. f10, 1 into minus 1, minus 1. f into 11 is minus 1 into 1, minus 1. f12, minus 1 into 1, again minus 1. f13, minus 1 into minus 1, 1. f14, 1 into minus 1, minus 1. And by now, ideally, you should be able to see repetition happening. See how I'm able to recognize the repetition is, I got 3 minus 1s here, I got 3 minus 1s here, I got 2 positive 1s here, I got 2 positive 1s here, I got a 1 and a minus 1 here, I got a 1 and a minus 1 here. Essentially, what I've identified is, after every 7 terms, the series repeats itself. After every 7 terms, series repeats itself. So when I'm looking for f of 694 and f of 695, I'm not really looking for this. I'm looking for their remainders with 7. So f of 694, 630 gone, so 64 left. This is as good as f1 and f2. It's as good as f1 and f2. f1 and f2 are 1 and 1. So the answer to this question will be option D, 2. Simply. Okay, moving on. Given gx is a function such that g of x plus 1 plus g of x minus 1 is equal to gx, where x is a positive real number, or what minimum value of p does the relation g of x plus p is equal to minus gx necessarily hold true? Okay, again, now this is a fairly common function that gets tested in tests, in mocks. So it should be there in the back of your head. Repetition here happens after a very, very nice number. But here, how we would go about doing it? See, out of all these terms, which is the largest one? This one. So let's put that highest up. We write it as g of x plus 1 is equal to gx, the prior term, minus the even prior term. So if I go g1 is equal to a, g2 is equal to b, g3 will be equal to what? B minus a. g4 will be equal to what? B minus a minus b, which is equal to minus a. g5 will be equal to what? Minus a minus b plus a, so it becomes minus b. And g6 will be equal to what? Minus b minus a, which will turn to a minus b. Then g7 will turn to a minus b will turn to a. And this is the spot after which repetition will start happening. g8 is a minus b. This will turn to b. And as soon as the first two terms are ab, everything else falls in place. It will start repeating itself. Now the question was g of x plus some number is equal to minus of gx. If g1 is a, where am I getting minus a? I'm getting it at 4. I'm getting it at 4, which is 3 forward. Answer to the question is option B, 3. Next one now. Now fx is equal to max function, which is 2x minus 6 and 4 minus 3x. Again, we can draw the graph, we can do everything. We, of course, don't need to draw the graph. We, of course, don't need to draw the graph every time, especially when you have simple questions like these. But in case you want to draw the graph, in case we are looking to draw the graph, let us go ahead, draw it. First one would be, the place would be 3. Yeah, 3. And the slope would be 2, something like this. This is 3, this is 2. Here, the slope would be minus 3 and it is going through. The point would be 4 minus 3x slow this time. So 4 by 3. The root will be 4 by 3. And the line will be going something like this. This is how the graph would look. Now, because this is the max function, this portion of these two graphs would be relevant for us. Of course, this keeps on going, this keeps on going. Now, the point where they meet, we can do that graphically also. And we can also, of course, equate them and get to that point. But look at the individual questions within this set. First is, what is the value of fx at x equal to 10? All you have to do is put x equal to 10. Here we get 14. Here we get minus 26. Again, this is a max function. We'll take the larger value out of the two. Answer to the first question here is 14. Then what is the minimum value of fx? The minimum value of fx is when they are equal. So 2x minus 6 is equal to 4 minus 3x, or 5x is equal to 10, or x is equal to 2. Remember, this is the value of x where minimum value is achieved, not the minimum value of fx. Minimum value would be when x is replaced here. 2 into 2 minus 6 gets me to minus 2. Answer to the second part is going to be minus 2. Now for this final part, see, max min function, min max function, they are simple. But here we are looking for a maximum value of fx if x lies in the range -5 to 10. Then what do we have to do? Then what do we have to do? We simply see -5 would be somewhere here, 10 would be somewhere here. We simply find out values at these extremes itself. This is where minimum of the function would lie. You simply find out value at these extremes. X equal to -5 and x equal to 10. When x equal to -5, I'll have -5 into 2 is -10, -10 minus 6, -16. -16, comma, here I would have 4 minus 5 into -3 is 15. So 19. Given it is the max function, of course, at -5, the value that will be accepted is 19. Now, when x is equal to 10, we know the value of the function was 14. So what is the maximum value of fx if x lies in the range -5 to 10? The answer to the question is 19. Within this range, the maximum value fx can take is going to be 19. And that is the entirety of this question. Okay. Next. A polynomial fx with real coefficient satisfies the functional equation. Fx into f of 1 by x is equal to fx plus f of 1 by x. If f2 is equal to 9, then f4 is equal to what? Okay. Now see, for this one, two terms are multiplying, reciprocals of each other, and their summation is also turning out to be identical. Two terms are multiplying, and their summation of those two terms is equal to product of those two terms. How will that be possible? How will that be possible? Let's see. This is a special case where you have to take fx is equal to x raised to some power plus 1. X raised to some power plus 1. This is a special case that you should be aware of. Then what this enables us to get to, see what this enables us to get to is, if fx is this, and f of 1 by x is equal to 1 by x raised to the power k plus 1. Why this is interesting? Because now if I multiply these two, x of k plus 1 into 1 by x raised to the power k plus 1, multiply these two. First two terms will multiply to give us 1. Next two terms will multiply to give us x raised to the power k plus this and this multiplies to give me 1 by x raised to the power k. 1 and 1 multiply to give me 1. This indeed is fx. This indeed is f of 1 by x. So this is how this breaks down. Now, with this knowledge in mind, can we write it as f2 is as good as 2 raised to the power k plus 1. And this we have been told as 9. So 2 raised to the power k is equal to 8, or k is equal to 3. Once we've got this, our standard expression is going to be fx is equal to x raised to the power 3 plus 1. Finally, we are looking to find the value of f4. So f4 will be equal to 64 plus 1 or 65, or option C will be the right answer. Option C will be the right answer. Next question. If x is the greatest integer less than or equal to x, then find the value of the following series. Okay. Under root 1, under root 2, under root 3, under root 4. Now see, from under root 1 to under root 3, each of these terms, there are going to be 3 terms, and each of these terms is going to give me value as 1. I will get value of 1 for 3 terms. Now from under root 4 to under root 8, I'm going to get value of 2 for 5 terms. from under root 9 to under root 15. I'm going to get value 3 everywhere for 7 terms. Now, this is hopefully something that we have already encountered in our solving in several places. But if not, can you see the series that is getting created? This is 1, 2, 3, so on and so forth. Because this is going on till 361, there is going to be a root 361 right at the end. But prior to this, it is going to be under root 360 and root 324 prior to that. 361 is 19 square. So we are going to get a value of 18. And how many times are we going to get a value of 18? Can you see? The subsequent term, the second term here is always 2 times the first number plus 1. 3 is 2 into 1 plus 1. 5 is 2 into 2 plus 1. 7 is 2 into 3 plus 1. So here also predicting the next term is going to be simple. This is going to be 2 into 18 plus 1. And this is of course going to give us a 90. Now we have to find out sum of all this. Of course, the expectation is not you will find out individual individual products 18 times and then add a 19 and then get your final answer, because that is going to be far too painful. That is going to be far too painful. But what we can do is we can find out for this is an AGP. This is not an AGP, but this is a quadratic AP. What I mean by quadratic AP is one part is moving in an AP, another part is moving in an AP. So we can come up with a general term for this series and then come up with a summation expression. General term of the series is going to be n into 2n plus 1. This is the general term of the series. This is term 1, this is term 2, this is term 3. This is 18th term. If I open this up, general term would be 2n square plus n. And summation for this general term is going to be 2 times of n into n plus 1 into 2n plus 1 divided by 6 plus n into n plus 1 whole thing divided by 2. This is the summation up till n terms. We know value of n has to be 18. I can put that down. 2 into 18 into 19 into 37 by 6 plus 18 into 19 by 2 plus 19. This is my final answer. This 19 that had not been included so far, I've also included that 19. Now, you can of course use the calculator, arrive at the answer, but I am a lazy person. I don't want to use the calculator. So I'm looking for ingenious ways to reduce my work. First thing I will do is I will simply get rid of the denominators. This 6 and this 18 goes away to give me 3. This 2 and this 18 goes away to give me 9. I now look at the first term is even, 2 into something. The second term is odd, 9 into 19. And the last term is also odd, 19. So even plus odd plus odd. Final result should be even, which helps me rule out option B and option D from consideration. These two cannot. Now, usually my next go-to move is looking at the unit digit. But because the unit digits here are identical, that wouldn't fly. Unit digits are identical, that wouldn't fly. So now I have to look for a way by which I can differentiate between these two numbers. I see this number is a multiple of 3. And I see this number is a 3k plus 1 kind of number, basically not a multiple of 3. So now my next check is going to be, is this expression a multiple of 3 or not a multiple of 3? If it is not a multiple of 3, I will mark A. If it is a multiple of 3, I will mark C. I will not do the full calculation. Why I'm talking of this is in exams like XAT, in exams like NMAT or SNAP. At that time, if you sit down to do 2 into 3 into 19, 19 into 6 is 114. 114 into 37 is how much? Then you add 192. That process should not go on for so long. So how do you reduce your work? You look for clues like unit digit and divisibility by 3 and all that jazz. I see the first product is going to be divisible by 3. There is a 3 involved here. The second product is going to be divisible by 3. There is a 9 involved here. But this last thing is not divisible by 3. So the final answer I reach should not be a multiple of 3. And therefore the final answer should be A. final answer should be A. See, there are layers to this question. First is identifying what all needs to be added up. Then identifying that for this series, you need to have a general term which can, this is a quadratic AP in action, summation for that. Then when you have this expression, how do you can either go ahead and calculate it in long way, or you can simply look at the small bits by which you can reduce one. Why I'm telling you all this is like the standard CAT question of the modern era, where you have 3-4 layers, Now, once who are able to reduce the working, will be able to do many more questions compared to those who are doing it in the traditional way. If you do it traditionally, I'm guessing it will take you somewhere around 5 to 6 minutes to solve this in the traditional fashion, which I'm guessing is not ideal. Okay, last question now. For how many positive real values of, find how many positive real values of x satisfy the equation 2 times of x square plus 5x plus 2, where x something denotes the greatest integer less than or equal to x. Now, this is more about notation formation. Let's say x, the variable x is equal to the integral part plus the part that comes after the decimal. This is known as the integral part. This is the part that comes after the decimal. Now, in standard textbooks, you would see these symbols getting utilized. Because I'm lazy, I'm going to say the integral part is A, the decimal part is B. The integral part is A, the decimal part is B. So what I do have is 2a square is equal to 5a, this is 5x entirety, 5a plus 5b plus 2. Now I can reframe this as, see, b is a solitary variable. So b will be equal to 2a square minus 5a minus 2 whole thing divided by 5. Now remember, b was the decimal part. Because b is the decimal part, it has to be greater than 0 and it has to be less than 1. It has to be greater than 0 and it has to be less than 1. This expression has to be greater than 0 and has to be less than 1. Let's see what all can we identify. When it is greater than 0, we would have 2a square minus 5a minus 2 is greater than 0. Or 2a square minus 4a minus a minus 2 is greater than 0. 2a minus 2 minus a minus 2 is greater than 0. So 2a minus 1 and a minus 2 is greater than 0. What this implies, see, the two roots are identified as half and 2. What this implies are, this part of the axis is accessible, this part of the axis is accessible. Any value between half and 2 is not acceptable, because here is where the function would give us a negative value. So anything greater than 2 is fine, anything less than half is fine. Anything greater than 2 is fine, anything less than half is fine for A. A has to be either greater than 2 or A has to be less than half. This is what this expression tells us. Now, when this B is less than, then I get 2a square minus 5a minus 2 is less than 5. This 5 comes over. We get 2a square minus 5a minus 7 is less than 0. So we get 2a square minus 7a plus 2a minus 7 is less than 0. We take out a common, 2a minus 7 plus 1, 2a minus 7 is less than 0, which gives us a plus 1 and 2a minus 7 is less than 0. Now what this implies graphically, see, the two roots are minus 1 and 3.5. Because the product of these two portions have to be less than 0, everything within this range would be considered acceptable. This is the acceptable range. This is the unacceptable range. This is the unacceptable range. Okay. Now see, we are looking for positive real values. Positive real values. Or let me write it also. A is less than 3.5 and B is not B. A is also less than -1. Less than -1 and less than half. See, on the left-hand side, of 0, A is less than half and A is less than -1. See, both these conditions have to be followed. And if it has to be followed, you will not get a positive real value. So on the left-hand side, there are going to be no values. In fact, remember, we are looking for A. A was the integral part. A was the integral part. A being less than half implies the greatest integral value that I can take is 0. But 0 is not fine. 0 is not fine. Here, I also get the condition A has to be less than -1. All the verse has been made. On the right hand side, the ranges that I get is A is greater than 2 and A is less than 3.5. This gives us an acceptable value of A. A can be equal to 3. It is greater than 2 and it is also less than 3.5. It is greater than 2 and it is also less than 3.5. This is excellent for us. I have made a mistake. It should not be less than -1. It should be greater than -1 and less than half. For these two conditions operating simultaneously, we do have a possible value of A being equal to 3. But for these two conditions, these orange conditions, you cannot have a possible value. You cannot have a possible value at all. So with that said, if A is equal to 3, let us go ahead and put that down. That this is not the end of our working. At A being equal to 3, we also have to check. If we are getting a value. We have to also get to a value of B, which will be equal to 2 into 18 minus 15 minus 2. So 18 minus 17, this will be equal to 1/5, or B will be equal to 0.2. Go back and put it down here. 2 into 9 is equal to 5 into 3.2 plus 2. On the LHS, we are getting 18. On the RHS, we are also getting 18. 5 into 3.2 is 16. 16. So yes, there is one acceptable value. There is one acceptable positive real value of X satisfying this equation. The answer to the question was how many? So the answer will be option B, 1. And that is the entirety of the questions for this week. Hopefully you learned something. Hopefully some insights were useful for you. And there were things that, as in, I have solved a lot of questions in which I have included things that were not really needed for solving that particular question. Hopefully that helped you. That will be all for this week. See you again next week. Okay, bye.